Bad Will Hunting is a team that has collaborations between Daily Maverick from South Africa, Follow the Money in Netherlands, and The Guardian in the UK. They basically explored whether AI can help identify bad actors or persons of interest in large data sets and learn quite a bit from it. So to explain more about the project, I'd leave it to Louise, Dimitri, and Alet to talk more about it.
Thank you, Lakshmi, and hi, everyone. As she said, we are Team Bad Will Hunting, and we are The Guardian, Follow the Money, and Daily Maverick. So when our teams got together at the start of this fellowship, we all had more or less the same idea in mind, which was how do we employ an AI solution to make it easier and faster for journalists to identify so-called bad actors in data leaks. All through our teams do a lot of investigative journalism, and our journalists are often in a position where they need to sift through large amounts of digital documents to find people of interest and connections between people and companies or other institutions that indicate possible wrongdoing. And while the digital age has given us unprecedented access to sources of information that were previously unobtainable, it also means journalists have access to more data than they could ever process manually. And of course, it takes time and resources to work through these documents. So this is the problem that we wanted to solve, and we set out to do so in the multi-step approach you see on this slide here. We focused our efforts on B, which is about identifying the real-world person linked to each name identified in a text, as Luis will now explain.
So thank you, Alet, for that great presentation. One solution to this problem that Alet was just describing is to train a specific kind of machine learning model called an entity linker. This type of model learns how to link the mentions from a document to unique entities within specialized databases, typically known as knowledge bases, thereby providing real-world information about the mention. So an entity linking model then bypasses some of the manual work that is required in getting the context behind each mention. And this context can be employed for journalistic use cases, such as looking for people of interest for a story. Now, given the scope of the fellowship, we had to focus our approach as much as possible. So we decided to use Guardian articles from the past 10 years as a stand-in for a large pool of digital documents containing relevant mentions. This had several advantages, like the data being readily available with minimum pre-processing required, and also containing many well-known mentions to develop our approach on. In this slide, I'm showing you a flowchart which represents the pipeline we built in the project. And over the next few slides, I will explain its main components. So first of all, we needed an element to actually extract the mentions from text. This is called a named entity recognition model, or NARE for short. And what it does is it scours through the text, locates the mentions, and classifies them into predefined categories such as person, organization, and others. To extract our mentions, and throughout this project, we relied extensively on Spacy, which is an open source package for natural language processing with Python. In this figure here to the left, you can see an example of the result from Spacy's NARE model detecting several mentions across categories. But in this project, and for simplicity's sake, we decided to focus our prototype exclusively on person mentions. In addition to these relevant mentions, entity linking requires a second dataset, namely knowledge bases containing relevant entities and the information about them. Our intention for the fellowship was to work with knowledge bases of interest in investigative reporting. So rather than using a general purpose knowledge base like Wikidata, we decided instead to combine two open access knowledge bases, which some of you might have heard of or even used, LittleSys and Open Sanctions. Curiously, this decision, which was one we took very early on in the project lifecycle to merge two knowledge bases together, ended up being one of the most critical choices for us and the source of some of the challenges we had to resolve in the project. Because these two knowledge bases have no affiliation with each other, we did have to spend quite some time dealing with inconsistent formatting and cleaning the data by resolving duplicate entities and combining information across them. Okay, now we had our inputs in place and we could start thinking of training an entity linking model. Machine learning models learn to make predictions by generalizing from thousands of examples. This means that to train our model, we had to generate a training data set. And this is a data set containing many examples of mentions extracted from Guardian paragraphs and manually linked case by case to the correct knowledge base entity. This process, or an example of this annotation process, is illustrated in the left of the slide, which shows a Guardian paragraph on top, a mention highlighted in yellow, and just below, a list of plausible candidates for that particular mention. The annotator's goal was to find the correct match from this candidate list by ticking the right checkbox in the interface. But before we could even proceed with annotation, we still had to resolve two issues. One was that the number of candidates was often too large due to the sheer number of entities in the knowledge base. So we had to shorten this list of plausible candidates as much as possible in every case. To do this, we developed an algorithm to filter through thousands of candidates down to the top 10 most plausible candidates per mention. And the main steps are kind of summarized here in the right side of the slide. In short, the algorithm weighted each candidate based on fuzzy string matching and also the shared words between the paragraph and the knowledge base descriptions. And it achieved very good results, so we're quite happy with it in terms of ranking the relevant candidates high enough for annotation in most cases. The second issue we still had to address was also to define a set of annotation guidelines. This is because by asking annotators to follow standard rules, we ensure quality and consistency in the training dataset. The chart here in the slide summarizes the annotation instructions. You can see there were 3 binary decision steps in light brown, and depending on the particulars of the example, there were 5 possible annotation choices in shades of blue. Altogether, we had a team of 9 annotators working for a combined total of around 40 hours to produce more than 4,000 examples for our entity linking. Now we had all the pieces in place, and after several months of work, I'm quite happy to say we were able to train an entity linking model prototype. After training a model, inevitably the next step is to evaluate performance. Based on an early analysis, the accuracy of our model, we estimate, is around 70% on an independent test dataset. However, when we did look at the predictions more closely, we realized the model was still struggling with linking single name mentions to the correct entity. And we think this was likely just due to not having enough of these examples in our dataset. On the other hand, the valuable insights we did gather from this analysis will help us target improvements in future iterations, and we aim to accelerate the data generation step and cover the model's blind spots. That's all from my side. I'll now pass the word to Dimitri to summarize some of the learnings from these past few months.
Thank you, Luis. So it was extremely challenging to devise a one-size-fits-all solution for resolving entity names. There are many different training sets, languages, and knowledge bases that each heavily impact the quality of the results. So a lot of effort was therefore needed for finding and really understanding the knowledge bases before we could start implementing a pipeline. We had to make a lot of choices. For instance, how many candidates were shown to the annotators and how we would rank these candidates. And it was really hard to find a good training data set. We wanted to find people that shared a name in close proximity to each other in a text, so that the model can learn how to spot the difference between them. Do we mean Boris Johnson, the Prime Minister, or Boris Johnson, the carpenter from Cornwall? Also, we struggled how to validate the results. How do you measure a good model performance? And we learned that annotation guides must set very clear and consistent rules. There are many edge cases that still gave us a headache. For instance, we encountered the entity God. Should we classify the God as a person? And how about Santa Claus? These are real examples we had. So what are the next steps? If we have a working model, we can extract and identify or qualify the most important entities, not only persons, but also companies and organizations. And we can tell one entity from another, even if they look similar to a machine. We want to find the relationships between these entities in a text. Does a person belong to a company? Can we search for these patterns in large archives of semi-structured documents? And can we use this information to make more reliable statements if somebody is important to our investigation? And finally, we want to set up a process or recipe so that every newsroom can tailor our model to their own specific needs. The model should be adaptable to different languages and different investigations, so that once journalists are confronted with large data leaks, they can find the bad and interesting actors sooner. Well, thank you for listening. We would be very happy to take your questions you might have.